Okay, so here's the next example. And so in this case, we're talking about the set of all polynomials with real coefficients. So in this case here, like the other example where we had P3, this includes all third-degree polynomials. In fact, it includes 30-degree polynomials, 300-degree polynomials. In fact, of all the polynomials, the degree is without bound. Even though any particular polynomial in here has a finite degree, the set itself is without bound as far as the degrees go. So, when we talk about this set, by the way, this is also a vector space, we can look at this as like an infinite tuple, right? Just like the previous example where we had infinitely tall vectors, this would be like an n-tuple, an infinite tuple, right? So the correspondence would be to the coefficients, right? So for example, if I had 135. Right? So even though that has a finite degree, right? It's a second degree polynomial, but it would correspond to the n-tuple that would be 1, 3, 5, 0, 0, and so on. So it'd be an infinite tuple that would correspond to that. So where all of the following entries after 5 would be 0. Okay? And so in here, each member of the set has a finite degree under the correspondence. How do I say this? Each member of the set has a finite degree. Under the correspondence, there is no element from the space matching that. So here's what, so if we take the other example where we had this, how do I write it? The function 1, 2, 5, 10. Right? So there's no element from this space here that would correspond to this. Okay? Vectors in this space correspond to infinite tuples that always end in zeros. Okay? So there'd be nothing in here that would correspond to this, given the previous example. Okay, that's it.